I want to find the focus of this parabola. Now how do I know it's a parabola? Well, if I only have one piece squared, like either the x or the y squared, I know it's a parabola. Now in order to find the focus, you first need to get it so the non-squared values by itself, meaning I only have y equals. So what I'm going to do is I'm going to divide by -9 to cancel this off. And what I get is I'm going to put the y over on this side, just to make it clear. And this side, 12 divided by -9, looks like it's, well, 3 goes into both, so it'd be -4/3 x squared. Now, from there, to find the focus, I need to find c. C is going to use this number. The formula to find the focus is c equals 1 over 4a. That's the formula to find the focus. So using that formula, this is your a value. Now before I even start, let's just think. Since it's y equals, and this is a negative, what you should realize is it's going to be going, y means it's going up or down. Negative means it's going down because it's negative. So we know right away this is going to be going down with the focus somewhere inside like that. So if we find the focus, well, it's 1 over 4 times, and what do we plug in there? Well, a looks like it's -4/3. So when we do the math there, it looks like we're going to get c equals 1 over, this is like over 1, so 4 times -4 is -16. 1 times 3 is 3. And when you flip that, because when you divide, you flip and multiply, so it looks something like this. Be 1 divided by -16 over 3, and then you're going to flip and multiply, so it actually ends up being, let's see, 1 times -3 over 16. So in the end, you got c equals -3 over 16. Which, what that means is c is how far your focus is from your vertex. This is your vertex, and we're going to go down -3/16. So down means it's y. Also, because the y is here, it's y equals, we also know the c goes into the y. There's two ways to kind of spot where it is. So basically, a lot of people mess up. A lot of people put it in the wrong spot. But because it's y equals, the c is in the y value. Also because it's going down, the c is in the y value. So there's two ways to kind of picture it. Now, number 2, it wants the radius. Well, the radius is r. First thing you need to do is divide everything by 2, because to find the radius you need to get the x squared and y squared isolated, all by themselves. So when you divide by 2, you get y squared plus x squared equals, that looks like 45. And then your radius is simply going to be the square root of this. So what you get is the square root of 45, which you actually can break down 45. 45, hopefully you realize, is the square root of 9 times the square root of 5. The square root of 9, what you should realize is 3. So my answer simply is, that's 3. 3 times the square root of 5. That would be my radius. Now if I was to approximate that, we'll go back up to 45. 45 is really close to 79. The square root of 79 is 7. So it's a little bit below 7. So it's probably like 6.8 or 9. I don't know exactly, but it's something pretty close. That's an approximate, because that helps when you graph it to actually draw it. You want to be able to approximate your decimals of the radius. Okay, for this one, if I want the co-vertices, well, the co-vertices are your b value. The vertices are your a value. This is an ellipse, so actually not yet. It is an ellipse, but let's change the form. And what we're going to do is we're going to divide everything by 30. Because for an ellipse, you always need it equal to 1. So 3 and 30, that reduces down to an x squared over, 10. Plus, this gives us a y squared, and that would leave us, 10 and 30, 10 goes into both, that leaves us 3 and 1. Now, from there, if I want my co-vertices, I need to focus in on this, the one with the smaller denominator. I want the smaller denominator, kind of a long word. I want the smaller denominator, that's b. The bigger denominator is a. So if I want b, b squared is equal to 3. So the bottom, that's b squared. So if you square root both sides, what you get is b equals plus or minus the square root of 3. Now the next question is, okay, good, that's the distance to from the center to it. Let's think about this graph real quick. Since the x is the bigger number, what you'll realize is this graph kind of goes like this. Okay, the vertices are here, the co-vertices are here. That's your center at 0, 0, because the bigger numbers and the smaller numbers. So these co-vertices are right here. There's the smaller distances. So if I want those coordinates, well, didn't we go up square root of 3 and down square root of 3? So this would be 0 plus or minus the square root of 3. Those are your co-vertices. Now you could find your vertices, which are right here, but those would be your co-vertices. Be aware of that. B is your co-vertices. Last question. This is a little bit more complicated for people, but we want the asymptotes. First thing you have to do for this hyperbola is divide by 100, because again, with hyperbolas and ellipses, it has to equal 1. So it looks like what we have here is x squared over, well, 4 goes into 100, looks like 25 times. And 25 goes in that 4 times. And we're equaling 1. From there, if I want to find my asymptotes, what you might want to do is make a quick little sketch. How you sketch this is you look at the bottoms and you make a little box. Instead of an oval, it's going to be a box. And your box is going to be 5, because the square root of 25 is 5. 2. So the x is 5, because it's under the x. The y is 2. It's under the y. So it's 5, 2. So it's going to be over 5 and up 2. So if I make this little box, it's going to be, have a box. Okay, here's the center. You're going to have these asymptotes. Now, it's for the box, what you realize is you have this asymptote and you have the slope. The 5 comes from the x, so we're going to be going over 5. The 2 comes from the y. So these asymptotes, if you look at this box, it's up 2 over 5. You can see an asymptote. The slope of that asymptote, remember slope is rise over run. So if we want the equation for the asymptotes, there's a positive one and a negative one. Positive slope, negative slope. The slope looks like it's 2 over 5, up 2 over 5, and x. That would be the equation of this asymptote. Both of them. Up 2 over 5 for this one and down 2 over 5 for this one. That's why there's 2 of them. Now, just real quick, if we were to sketch this, since the x is first, these would be, the hyperbolas would go to the side, but that doesn't matter if I'm looking for asymptotes. Hopefully this helped.